When I first started with Pwn Adventure 3, I thought I would have to implement a network proxy and reverse engineer the protocol much earlier. I didn't think that debugging the non-strip binary would be this powerful. But we are slowly heading to the more complex challenges, and I wanted to do a network proxy eventually. So now is the time. According to Wikipedia, in computer networks, a proxy server is a server that acts as an intermediary for requests from the clients seeking resources from other servers. So we want to sit between the client and server to inspect the traffic and maybe even manipulate it, like a man-in-the-middle attack basically. So from our very early Wireshark investigation, we know the game communicates over TCP and is contacting a master server on port 3333 and then a game server on some port between 3000 and 3005. If you don't know how TCP works, I recommend you to watch my TCP introduction video from a long time ago, which should make a lot of stuff clear. We also know that we can control where the game tries to connect to by manipulating the IP of the servers in the etc host file. So let's start by pointing the client to a different IP, our proxy server, and for me that is my MacBook. I want to develop the proxy server on my day-to-day machine as that's most comfortable to me. So when we now try to log into the game, the client would try to connect to the master server, which is now pointing to my MacBook. But of course, there is no server listening on port 3333 on my laptop yet, so that will fail. But what is our high-level plan? To create a TCP proxy, we want to essentially open a port on our machine so the game client can connect to us. But then we also want to connect to the real server and forward any packets. But forwarding might be a misleading term here because we are not really forwarding the packets. We are actually opening a socket to listen here and fully receive the data. So now we just have the content of the TCP packet in our hand. And then we have another socket open with the real server where we then take the data and send it out. So we fully unwrap the packet, look at the content and repackage it again for the real server. And of course, we also want to handle answers from the server, which we unwrap, look at the content and then repackage it by sending it over the socket to the game client. And we basically have to do this twice for the master server and game server as these are the two separate connections. Okay, high level plan done. Next, let's plan our program that does that. I'm not a networking expert, so my engineering solution is probably not the best way to do it, but as long as it somewhat works, it's an okay prototype and proof of concept to see if what we want to do is even working. So essentially, we want to open a listening socket for the game client to connect to, as well as establishing a connection to the real server. These are the two different connections that could receive data at any time. So these components would have to be placed in their own thread. I call one the game to proxy thread and the other one proxy to server thread. And then we also want to connect them somehow, because when the game wants to send something to the server, it arrives in the game to proxy thread, which then has to send it out to the server socket that is used in the proxy to server thread. So we have to exchange references to each other's sockets as well. And that's basically it. In each of the functions that receive the data, we can then program anything we want and do with it before forwarding it to the other socket. But because we have to deal with not only one server, but we have a master server, as well as up to 5 game servers, we could bundle the creation of the two components into another general proxy thread. So we can easily create multiple instances of that. Cool. So we have a little bit more detailed technical plan, so now we can go another layer deeper and start looking at the actual implementation. Because I'm most comfortable with Python, I decided to write my proxy in Python, and so we can use the threading module to create thread classes for our general proxy, as well as the game to proxy and proxy to server thread. And we can use just low-level sockets to implement the network communication. Let's start with the proxy to server. That is supposed to be the thread that handles the connection to the real game server. So we start by creating a class game2proxy which inherits from thread. This allows us to define a run method that will run in the thread. So in here we could create a while true loop that handles the data and network connection. But before we continue in here, we should set up the server connection first, which I do in the init method. This is the constructor. Because we override it, we have to make sure to still call the original init function. And then we create a new socket, which is just a basic socket example taken from the Python docs, and connect it to the host and port passed into the constructor. So later we will give it the real server IP and port here. We keep a reference to the server connection in the object variable or attribute server. And then in the run method, which will loop forever in a thread, we will attempt to receive up to 4K of data from the real server, which means if we get some data back, we want to forward it to the game client. So we don't have a game client connection yet, but if we have one, we can then call sendAll to forward this data. So self.game will later be the socket that is then connected to the game client. But that socket is created by the game2proxy thread, so let's create that thread class next. Class game2proxy and also base class thread. In that init function, things are a bit different. We also get a host and port, but this is where we want to listen. This is the proxy part where the game tries to connect to. So the socket we create will then bind to the host and port given by the parameters. This again is just a basic Python socket server example taken from the official docs. And then we call accept, which will wait for a client to connect. Once a client connects, we get the socket to communicate with that client and we assign it to self.game. Then in the thread run method, we loop forever and see if we have data from the game client. If we did receive something, we would try to forward this data to the server socket. That's the socket created by the other class. So now we have to hook them up both. We have to create both threads and give each of them a reference to the other's socket. For that, I create a third more general class called proxy, which is also just a general thread setup, but then in the run method, we create the game2proxy thread object, which will wait for a client to connect to the port specified. And if we get a connection, then the proxy to server will establish a forwarding connection to the server. Now both threads created their respective socket, and now we just have to exchange them. So the one that talks to the game client has the socket to forward data to the real server, and that the server that has a socket to the client to forward back answers. That was just the setup of the threads, and then we actually start them. This will kickstart executing their run methods. Now the only thing that is missing is to create that proxy thread, or actually multiple proxy threads. Let's start with the master server, which will listen on all interfaces on port 3333 and forward them to the real server IP. This is where my real server is located. And then we start that thread. And then we launch multiple proxies for all the possible game servers that the client might want to connect to. So 5 additional proxies for port 3000 to 3005. And this should already work. Let's add a small debug output into the threads and see if we can see the traffic. To identify where the data was coming from, I include the port as well as an arrow to indicate the direction. So one is the stuff the client sends and the other is what the server answers. Then let's start it. This looks good. All of our proxy servers are waiting for a client to connect. And when we now log into the game, we can see that data with the master server is exchanged. Keep in mind that I cut the output after 100 bytes, so the actual data might be longer, and it's hex encoded because it's binary data. And when we now join in the game, we can see a lot of messages on port 3002. So that's the game server. If we pause it for a second, we see that the client sent a lot of similar stuff, and the server responded with, I guess, empty data, just 0000, 20 bytes, probably indicating, yep, I'm still here, but I don't have anything new for you. The whole engineering challenge we have here is not to build the most performant or resource-saving proxy to handle thousands of connections or whatever. Our goal is to build something that allows us to explore, analyze, and play with the network connection. And to do that, I add 2 more things. By the way, if you want to exit the proxy, you will have to kill the process, but we will take care of that now. After the creation of the threads, I add a simple while true loop that constantly waits for input from us and then takes that as a command. So if we find a quit command, then we just tear down the whole thing with exit. And here we can expand the commands later. For example, if we want to inject our own packets, we could easily do that here. The other thing I want to do is the parsing and analysis of the data that is exchanged. And that is supposed to be an explorative, playful part. So it would suck if we always have to kill the proxy, restart it, log back into the game and check something just to do it all over again. So I decided to place the parsing into a second file. Here we simply define a parse function. This function will take the data as well as the port of the connection, so we can identify if it's game server or master server data, as well as an origin parameter to indicate if this data originating from the client or from the server. So we can import that parser module now, and in the loop where we handle the data we receive, we call the parser function with the corresponding parameters. So this data is coming from the server and this is data coming from the client. Though to get a really interactive, playful experience, we have to reload the module, because otherwise the function is loaded once when it's imported, and then when we make changes to it, it does nothing. So when we reload here the module, we always have our latest changes. Because our changes could be terrible, we have to wrap that in a try and except block to catch any exceptions caused by this. Let's try it. Going in game and we see all these messages. So this is the message that is coming from our parser function here. And let's see if we can modify it and see the changes. How about we only want to see data for the game server and only data sent from the client to the server. So we can check if this is a message from a server and then return. Now we only see client messages. Amazing, right? So we can start playing here and interpreting and parsing the data, and we don't have to restart the game proxy. And when we made a dumb error, we see the exceptions here and can quickly fix it. Before I send you off, let's just show you really quick what we can do with that now. So for example, we see here a message that never changes sent from the client to the server. But if we move in-game, we walk around a bit, we can see changes. But not everything changes, only in this area. If we stand still and jump up, then besides the other new packet we see, only this value here changes. So, do you have a guess what this data might show us?